Hi guys, so in this lesson I want to help you to understand the difference between what we call monolithic applications and microservices applications. So monolithic applications are more of a kind of old way of doing things, and they've got some significant limitations. And microservices is an architectural practice in which we can gain some significant benefits, and I'll explain to you all about that now. So in our monolithic application, let's just say that this is our application inside the blue box. This could be running on one server or multiple servers, but it has multiple components. So it's got, for instance, the storefront user interface. That could be some kind of web service that your users can interact with and place orders. It's then got a mobile interface for if they're using their mobile clients to access your website. It's then got an order service. So this might be when they've actually added something to their cart and purchased it, and it's going to process that information for them. The customers might log in to check their accounts, to update their details or see the progress of their orders. So there's another application component for account management. We then got the actual payment service. So this is your payment gateway. So when they place an order, it has to talk to the payment service. And we've then got a shipping service and a database for storing lots of information. Now, as you can imagine, there's lots of different ways that these different components are talking to each other. And this is probably not all of them. There could be a lot more than this. So it becomes very complex. And there's some significant limitations to this model. Now, in this model, we combine what we call the user interface. So the component that the users actually see. They log into a website or they access a website or a mobile interface. The business logic, so a lot of the processing of orders, the account management, the CRM layer and that kind of thing. And then the data access layer, so the actual place where the data is stored about that customer and about the orders they place and the statistics and information that we might record. So it's all combined on a single platform. If you have to update any single component, so these could be very different pieces of code. They could even have different development teams working on them, and somebody might need to update the mobile interface. Now, if you do that, you may well have to take down the whole application. Similarly, if an individual service fails, it can cause a problem for the entire application. Now, as I mentioned, you can have multiple instances of your application, but the application is all of those components of that application are running on each of your virtual instances. You might then put a load balancer in front of it and you've got users connecting. So there is some protection against an individual virtual instance failing because you've got multiple instances, but you still have the same code running on all of these applications. So if you do have to do some kind of updates or there's some kind of error occurring in them, it can take down the whole application. So what's another way of doing this? Well, rather than using a monolithic application, we can move to what we call a microservices architecture. So in this case, what we're doing is we're separating each component of our application. We will then often decouple them and connect them using APIs. We might put message buses in between so that we've got loose coupling, for example. And we may separate the databases so we have different databases for different components of the application to store information. So each of these is a separate application that's running, and it can be deployed as what we call a microservice, and that's an independently deployable unit of code. They're often loosely coupled and they're organized around business capabilities. So how does that look on Docker, for example? Docker is used for hosting containers, and containers are really useful for running your microservices applications. So for example, each one of these containers could be a separate microservice. So you've got your storefront microservice, your order microservice, your shipping microservice, and so on. And then you can scale that out to multiple containers across multiple Docker engines running on multiple physical hosts, which means you've got multiple instances of your application and you've separated them from each other. So you could have multiple instances of each microservice on a single host, or you could spread them across multiple hosts. So you've got lots of options. And remember, containers are super fast to deploy. So if something fails, you can redeploy it much more quickly. And they're also low in terms of their usage of underlying resources. So let's have a look at some of the attributes and benefits of microservices. So we talked about APIs earlier in the course, and APIs really help you to talk between your applications using standard languages. And in terms of loose coupling, it means you can integrate with things like a message bus using an API or a notification service to send information between your application components. We have independently deployable blocks of code, so each microservice is a separate block of code. Those can be scaled independently, so if one needs a lot more resources than some other component of your code, then it can scale without affecting the others or without causing any kind of constraints or issues on the other components. You also have what we call a business-oriented architecture, and that means that you can organize your development around your business capabilities, and the teams can be cross-functional, so they can work across different blocks of code, and they might even be able to reuse code across different application components. We also have the flexible use of technologies. So each microservice can be written using different technologies. So you might have different programming languages in use. Sometimes that can be difficult if you're running on a single underlying operating system. But when you're using microservices, it becomes a lot easier. And lastly, we have speed and agility. So remember, super fast to deploy microservices, and they're really easy to update. You can easily add high availability and fault tolerance using auto scaling and load balancing, just as you do with those other types of web service in the cloud. So I know it's a bit of a complex subject, especially if you haven't been exposed to this type of architectural discussion before. But the key thing to remember is that what you want to do when you're architecting your application is look for ways that you can be able to have the flexibility you need, that you can kind of separate the components of your application such that they can scale independently, that you can add high availability and fault tolerance, and you want to make sure you avoid having that kind of single point of failure where if one application component fails, it cascades to the other application components. And microservices is one example of an architectural pattern that you can use that really assists with that.